So hello everyone, welcome to our YouTube channel Vigyan Bharat. In today's video, I'm going to discuss a problem from CSIR Net June 2020 examination. As you can see, the topic of the problem is from numerical analysis, and it's a very simple problem as you can see, and it's based on the topic Newton-Raphson. So what we are given, let's first read the problem. Consider the Newton-Raphson method applied to the approximation of the square root of a positive number alpha. A recursion relation for the error En equals to xn minus under root alpha is given by, and these are the options for the representation of the error term En. So what we have to do basically, first we have to construct a function which approximates the square root of this number alpha. So basically we can say this in another way, that this alpha is a root, square root of this alpha is a root of this function. Basically this x takes a value square root of alpha. So now if we square both sides, what we get? X square equals to alpha, or simply x square minus alpha equals to 0. If now I choose my f to be, fx to be x square minus alpha, you can easily see that this f of root alpha, that is square root of alpha square minus alpha, which comes out to be the square of this term first, alpha minus alpha, it is 0. So this root alpha is a 0 of this function fx. So we find our f, what is the required function, whose root when we are approximating, the error term is given by this. These xn's are the approximations to this root alpha, and alpha is the 0 of this fx. And whenever we are approximating through the approximations, there will be certain error at every stage of approximation. So what we have to do basically, we have to find what will be the representation of our n plus error term at the n plus 1th iteration in terms of the n error at the nth term as well as the 0 of the function. So let me rub this, and now we have to recall the method involved in this problem. What is this method? Basically the Newton-Raphson method. So if you recall how the Newton-Raphson method is given, this is given by simply this. Of course, provided this f dash xn is non-zero for every xn. So what it gives basically, suppose you are given an initial approximation xn which is close enough to the 0 of the function which you are trying to approximating basically. So you are given an initial condition. Now you try to find the successive approximations using this formula. If now I substitute the value of f in this expression, what I get, xn is xn plus xn minus, what was our f of xn? If you recall, our fx was x square minus alpha. This was our fx. So now what I have to do basically, just substitute xn for x in this expression. So what we're going to get, xn square minus alpha. And now if you take the derivative of this function with respect to the variable x, you will going to get f dash x equals to 2x simply, and at xn it will be twice of xn. Now if we simplify it further, taking this as in the denominator, it will be twice of xn square minus xn square, so simply xn square, and this minus and minus will become plus. This is the expression for the n plus 1th iteration in terms of the root xn, in terms of the approximation xn and as well as this quantity alpha. Okay, fine. Now what we have to do, what we want to basically find the value of this expression en plus 1. What we have now, xn plus 1. Now in general, suppose this is our real line. Here is some number which I am calling my root. In our case it is root alpha, which I denoted by suppose x star, just for notation I am using. And if I choose some initial approximation, suppose say here xn, so now this distance, if you can see, this is the error en. What it is, what it represents, basically the error. Of course my xn in this case is on the right hand side of this root which we are trying to approximate. Basically this xn can be also on the left hand side. So in general, whenever you are talking of the error, if you want to take the absolute error, then we have to take the difference of these two and take the modulus of that. Fine. So you get an idea. Similarly, if I now, so what will be my en from here? My en will be xn minus square root of alpha. Fine. From here you can observe the difference, xn minus square root of alpha. This is my en. Error at the n plus 1 nth iteration. This n represent the iteration at which you are having this error. So what will be your en plus 1? Simply replace n by n plus 1. So it will be xn plus 1 minus square root of alpha. Fine. So now we have to find the value of this en plus 1 in terms of en square root alpha. So simply just replace the value of xn plus 1 which we have found here. So let me rub this again. Fine. So what will be your en plus 1? Xn plus 1. So it is this expression, xn square plus alpha over 2xn minus square root of alpha. Fine. Now I can rub this one also. It is not required. If I now take the LCM again, you observe this. This will be simply 2xn. This is xn square plus alpha minus twice xn square root of alpha. Fine. Now try to observe from the options which are given to us how we can manipulate this expression to rewrite in terms of the given expressions. If you see, if I again rewrite my first expression, it can be written as xn square. This alpha can be written as square root of alpha square. Fine. And now this can be written as twice xn times square root of alpha. I hope this is very clear to you. Twice xn. There will not be any problem in this. Fine. The above expression can be written as xn plus square root of alpha whole square minus xn minus square root of alpha whole square upon twice xn. But still now our expression is in terms of xn. What we want, our expression should be in terms of en. So we're now going to use this observation which was given to us. Simply replace xn minus square root of alpha by en. So this will become en square. And in the denominator, replace xn by, from here you can find the value of xn. It will be this square root of alpha will come on the left hand side and it will become en plus square root of alpha. Divide simply by twice en plus square root of alpha. Now we got our expression, the value of the error in terms of n plus 1th iteration, in terms of the values of the error at the nth step as well as the root. So from here, if you match the correct option, you can easily see that this third option, en square plus twice, yeah, this matches. So we got our answer. This is the correct answer. So I hope you got the clarity what was the problem. I explained it in a very detailed manner. You can simply, if you just want to just eliminate these problems, you can choose some particular values and then also you can do, but this is the explanation. So I hope you got the idea behind the problem. Thank you so much. Thank you so much for watching. If you have any problems, do drop me in the comment section. And there's a group, we are available on the Telegram. So if you want, you can join us there. Thanks so much for watching.